We will achieve 1.5 degrees by 2030 and at least 3 degrees by 2100. So most scientists in the field are pretty much of the opinion that keeping it to within 2 degrees by the end of the century is pretty much impossible by now.
Moves to reduce carbon emissions to counteract climate change and its effects have been slow.
It's vitally important, and it's getting more important with every passing day at the moment, because we just aren't doing enough of it soon enough, and it's been that way for quite a while. So when I was setting the context for my energy research, I went back to look at what our process has been over 30 years really of being alert to the challenge of climate change. And you can really see that all of our major institutions, governmental, intergovernmental, have been, in a sense, in a form of denial over just how big this challenge is, which you can sort of sum up with needing to provide clean, decarbonised economy for a 10 billion person planet with everyone at high living standards. And we just have not gone about the challenge in appreciation of that at all. And it shows, because now we're at 415 parts per million CO2 concentration. When I changed my mind on nuclear power, it was only about 390. This is really concerning. So we are on track to change the nature of our climate in this century in ways that are really going to change the way we occupy this planet for the much harsher and the much worse. So we have a big job in front of us, and people are still realising just how challenging that job is.
Some obvious results: the acidification of our oceans, a rise in ocean levels, and it's becoming a runaway effect.
Well, oceans are probably going to increase anywhere between 0.2 and 0.5 meters by the end of the century, although that's contingent on a model of gradual melt. And as we're seeing now from Arctic sea ice and Greenland ice sheet, that it's probably going to be more of a catastrophic shift. Also, the paleo data from mass pulses of ice and fresh water through the different interglacials and glacials events over the last 200,000 years or so show that it wasn't gradual. So we had these huge pulses, especially coming out of the North Atlantic, that changed sea levels in terms of meters in less than a few centuries. So we could be seeing a lot more. But unless we massively reduce our emissions, and we haven't been able to do that at all up to date. I mean, yes, we've increased renewable energy substantially, but our demand and our production of fossil fuel-based energy in particular is keeping way ahead of what any gains we're making from clean energy sources.
Another consequence of burning coal has been air pollution, and its effects on populations have been dramatic. Estimates suggest that in India alone, between 2011 and 2012, there were 111 coal-fired power stations. As a result, the country registered between 80,000 and 115,000 premature deaths, and more than 20 million asthma cases. Humans aren't the only species threatened.
Actually, these days we're getting a much better handle on the effect on life, from plants to insects to big animals, including us. And that's partially from better predictions and also better observations of what's happening today, but also looking into the past. Now, what we do know, at least over the last few glacial cycles, so going back, several hundred thousands of years, that when the warming events came, that's when we were seeing the big extinction pulses. So losing the mammoths and the saber-toothed tigers and the protodons in Australia, that actually was in most cases synonymous with a warming, or in the case of Australia, drying event, as well as humans coming in. So it was kind of like a 1-2 punch. So, and that was sometimes over the course of thousands of years. Now, we have a vastly increased rate of change, and there is adaptation to a certain extent, but in the areas where the thermal range is quite low, for example in the tropics, even though it's on average higher, the variance is quite small, sort of day to day or season to season. That's where we're likely to get the biggest extinction rates. Now, we've done some other modeling along those lines that makes it even scarier, because most of the models are contingent on exceeding thermal thresholds. So this thermal tolerance of species X, once you surpass it, the species goes extinct, and then you look at the species-specific thermal tolerances and you calculate how many you're going to lose. If you do it that way, you're looking at about a 5 to 10% loss by the end of the century on current projections. That's just from climate change. So that doesn't include anything like overexploitation or deforestation, invasive species, or pollution, or anything like that. So this is just in addition. Ecology doesn't work like that. So what happens is you get one species that will depend on a whole host of others. For example, it's simply a specific pollinator to a specific type of plant or tree or something like that, or a flower. When the pollinator goes extinct, the plant does. Or the other way around. Or I think of a predator and specializing in particular prey. If the prey goes extinct, the predator goes extinct. We call these things extinction cascades. And we just did some work last year that showed that not taking into consideration these extinction cascades underestimates the effect of climate change by up to 10 times in a warming scenario. Not only that when you try to break the system, and these are virtual Earths really that we're creating, when you try to make the worst case scenario to get the fastest extinction rate to total annihilation, it pretty much mimics exactly what's happening with the heating scenario. I mean, even I, who receives terrible news every day, was absolutely shocked by that kind of information. We have no idea how bad it's going to be.
But left unchecked, climate change will have massive effects on us.
Well, there's quite a lot to that, obviously, because it affects human societies in so many different ways. There's obviously the direct effects like heat waves. In fact, in Australia, the biggest mortality type from a natural disaster is not bushfires, it's not cyclones, it's actually heat waves. More people die from heat waves in Australia than any other natural event. Flooding, doesn't matter. So that's a direct effect. But we also have so many indirect effects, and one of those, of course, is food supply. Now, a lot of people might be thinking we're sort of at that optimum yield kind of threshold for most major crops around the planet. That's possibly true. There could be more intensification, but generally speaking, if you look at like some of the major crop types, like wheat, for every 1 degree of warming, you get about a 6% reduction. Now that's considering a linear prediction, which is unlikely to be. But water is another issue. I mean, we have already halved the water availability per person across the planet since the 1960s. So that's, of course, a function also of population growth. But water is becoming scarcer and more restricted to particular areas. So if we get major water emergencies happening in places like the Himalayas or that entire region of the subcontinent, you're looking at 2.5 to 3 billion people that depend on that water source that will suddenly have to find water elsewhere. It's already starting to happen in India. Australia is no stranger to water shortages. We are the driest inhabited continent, and yet we still choose to grow things like rice, and we can't seem to manage our largest river very well. So, you know, if we can't even do it, it's unlikely that many other countries would be able to. Not only that, human population will grow by about 35% by 2050. So we're gonna hit about 10 billion by 2050. We're likely to exceed 11.5, 12 billion by the end of the century. And because of most of that growth is in developing nations, we're going to actually have to double our food supply by 2050 just to keep pace. Because many of the developing nations are eating more meat, which is more both water and food intensive. And that brings about an associated lift in emissions. So, you think about emissions from electricity production only represent about 1/3 of the total emissions of a country. Agriculture is another third. So we have to get the agricultural side of things from a climate change mitigation in addition to just electricity supply.
Scientists and engineers have been growing more concerned every year.